We're going to be talking about absolute value and opposites today. So first I have 4 and negative 4 here. We're going to talk about the difference between those two numbers. So 4 and negative 4 are opposites. So I know that they're opposites because if I make a number line, 4 and negative 4 are the same distance away from 0. Okay, so that's how I know that they're opposites. So like 2 and negative 2 would be opposites. Negative 0.5 and 0.5 are opposites. So 9 and negative 9 are opposites. So opposites are pretty easy to figure out, but the reason we know they're opposites is because they're the same distance from 0 on either side. Each one of these is 4 away. Okay, 0's opposite would just be 0. Right, so here I have two absolute value problems. So these bars mean absolute value. Okay, so they're bars, they mean absolute value. They're not giant ones. So what absolute value is defined as is the distance away from 0. So if we look up at our number line, the distance away from 0 is always going to be positive. You can't walk a negative distance. Distance can't be negative. So absolute value is always going to turn positive. Okay? So the absolute value of negative 3 is basically asking how far away from 0 is negative 3. So absolute value of negative 3 would just be positive 3. Absolute value of 10 is asking how far away 10 is from 0 on the number line. So it's 10 spaces away. So basically all those absolute value bars do is turn the inside positive. So if it's negative, it turns positive. If it's positive, it stays positive. Okay, so let's look at some expressions here. Okay, so first one I have the absolute value of negative 3 minus the absolute value of negative 7. So I know it's tempting to want to deal with this minus negative first, but we can't do that. So absolute value bars kind of fall in the parentheses category of PEMDAS. So we're going to start inside them first. So the absolute value of negative 3 would be positive 3. I still have this minus sign. We haven't done anything with it yet. And then the absolute value of negative 7 is 7. So 3 minus 7 is going to give me a negative 4. So negative 4 would be my answer. Okay, next one. So absolute value of 20 plus absolute value of negative 2. So the absolute value of 20 is just going to be regular 20. So where they just, absolute value bars turn the inside positive. So if it's already positive, it stays positive. And I have my plus sign. And then absolute value of negative 2 is going to be positive 2. So 22 would be my answer there. Next one. Okay, so I'm starting inside my absolute value bars first. So I have negative absolute value of 3 plus 1 plus 6. So absolute value of 3 plus 1, so this is like the absolute value of 4 plus 6. So all I did was combine my 3 and 1 to get 4. So the absolute value of 4 is 4. And this negative sign, since it's on the outside of the absolute value bars, I'm going to include it. Okay? So if this negative sign was on the inside, it would turn positive. But since it's on the outside, it's going to stay in my expression when I'm writing my answer. So then negative 4 plus 6 is going to give me positive 2. All right, last one here. So absolute value of 4 is 4. And then this negative sign is on the outside of my absolute value. So I'm just going to write that down. It doesn't go away. And this minus sign I can bring down. Okay, and then here I have the absolute value of negative 5 plus 1. So negative 5 plus 1 is going to give me a negative 4. Okay, so this is where I'm at. So absolute value of negative 4 is going to be positive 4. I still have that minus sign and I have negative 4 out front. All right, so negative 4 minus 4 is going to lead us to negative 8. This is like we're at negative 4 on the number line and we're going 4 more negative. So I'm ending up with negative 8.